Hello and welcome back. Now today, at long last, as promised, we will start entering Siemens S7-1200 SCL code to control the factory I/O stacker crane. Not before time, you may say, so stay tuned. Now this is where we were in the last tutorial video, ready to start entering SCL code to control the stacker crane. I'll just save the program as part 9 video and I'll do the same with the factory I/O scene. That way it stops any confusion going forward when we have so many videos being produced. It actually helps me and not necessarily you. Just to find the videos. I'm going to start by opening tag table 2 and importing the tags we require, just as we did in the previous video, part 8. As I mentioned before, I've programmed this setup before, and when I did, I exported the tags so that I could import them again here, saving some time. So I'll select import, select the path, then I'll select part 9 video tags.xlsx and open, then OK. Then I can select OK at the import completed pop-up, and we now can see the additional tags required for this tutorial, from word to shift QD 108 to loading conveyor 1 weight M1.7. Obviously, if you're trying to recreate this project, you will need to enter the tags manually, just like we did in the part 1 video and also in the previous video, part 8, where I gave a brief introduction by adding in the first tag in tag table 2. Okay. As we can see, we now have 3 more internal bits added from M1.5 to M1.7. I seem to have forgotten about using M1.4. However, we can use that later in another video. Okay, let's go back to the main OB1, and in the reset bit field from M1.0, I can change the second field to 8. And enter. If we go back to the tag table, we can see the double integer QD108 with the tag name word to shift. We also need to move 0 into this at startup as well. I'll explain what we use word to shift for once we've entered some SCL code. Let's select main OB1 again and add the move command. And move 0 into word to shift QD108 and enter. Now we can make a start programming the stacker in SCL by selecting block _1 FC1. To make life a little easier, I'm going to use regions for each movement of the stacker crane we code. Again, this will be easier to explain once we've entered a few regions and some SCL code. Okay, let's select region and name it Initialize and then enter. You'll see the region list on the left update. Eventually we will have programmed a number of regions, and this is where we can access a point in the program quickly, and we will see that shortly. So I'm going to type in a description for the region, and I will type stacker busy, stacker ready to pick up pallet. Now I'll add an if statement and clear the comment as we've already entered one in the region. Now let's click in the condition field and enter some code. Let's just orientate factory I/O a little better to help explain what we're going to be entering. Okay, if the stacker is busy, meaning the reflective sensor 5 has been activated and the forks are in their mid position, and word to shift is equal to 0, then we are basically ready to go and pick up a pallet to place it in the rack. So I'll now set word to shift to 1, ready to take the first step, step 1 of a 9-step process. Now during the program, we'll be using a timer, and I'm just going to initialize the value for the timer now to ½ a second. Doing it this way, we can change the value of that timer in different regions of the SCL code to suit what we're trying to do. Now I'll just set up the timer so that it can be accessed throughout the program. I can't place it in the if statement, otherwise we wouldn't be able to use it unless the if condition was true. So create a region and name it timer 1 and add a comment. Now go to the timer operation and pull down AT on and place it in the region. The call options window comes up as we need a data block when adding a timer. I'll just rename it to IEC timer 1 dB and select OK. The timer is then placed in the region. In the timer we can see 4 fields that require entry. The first being in, Boolean in, which is required to start the timer. So if we select the field and type in timer, a list of 4 variables that we set up in the tag list then are shown. So we need to select timer 1 start M1.5. Then we select the PT field, which stands for preset time, and type in timer again, and this time select timer 1 PT MD10. We initialized this to ½ a second in the previous region. We could have put ½ a second directly into this if we wanted. Now let's go to the Q field. This is the output which is set true when timer PT value expires. Let's type in timer again and select timer 1 done M1.6. Then in the last field, the ET field, which stands for estimated time, we'll select timer 1 value MD104. Okay, I'm trying to figure out why these fields are yellow. Moving them over slightly doesn't help. Let's try deleting the bottom line. That's done it. Okay, let's move on. Now let's enter another region for the first step in the process, and we'll name it step 1 and enter. In the comment field, we'll enter extend forks left. I'll just make a little space between the regions. Okay. Now we'll add an if statement, and in the condition field, we'll check that the word to shift is equal to 1. Syntax error here. It should be just equal while checking a condition. So let's delete the colon. Now that I've done that, you can see the cross and the red underlining disappear. Now we'll come down to the next line and type in what we want to occur when word to shift is equal to 1. We require the forks to go left. So type in O_SC and select Q1.4, then colon equal TR and select true. This is what I love about having the tags set up. You only have to type in a few characters and a selection screen comes up. It makes life much easier than remembering the exact address. Now on the next line, as we have completed this step, we need to move the value of 2 into the word to shift so that we can get ready for the next step in the sequence, which is to lift the forks to pick up the pallet. Okay, let's just tidy up this a little and then enter another region. And name it step 2 and enter. Then in the comment area, type in lift forks to pick up pallet. I'll just tidy up the comments so the convention of capitals are the same. Great, now let's enter another if statement and check that the stacker crane forks have reached their limit. So in the condition field, type in I_S and select I stacker crane left limit input 2.0. It stays yellow while there is another comment below, so let's remove that and see what happens. And the yellow is gone. Now we need an AND, so we can then check the word to shift is equal to 2. Let's now lift the forks, so O_S and select Q1.3, then colon equal true, or 1, whichever you prefer for a Boolean output. So that will lift the forks to pick up the pallet. Now there is no limit sensor for when the forks are lifted, so we need some time before we can retract the forks inwards. So let's start timer 1, and the default of ½ a second is fine here. And to start it, we type colon equal true. And the final statement is word to shift colon equals 4, not 3, as I'll explain in just a moment. Looks like we've forgotten the semicolon after true. So let's add that in and remove the last semicolon and add 1 after the value 4. Now let's save what we've done and download the code to the PLC so that we can test what we've done so far. Let's search for the PLC. Okay, now load. And load again. Let's start the module and finish. I'll just go into monitoring mode and use the cursor to look at the right hand side of the SCL window, where you can monitor the I/O if you prefer to do it this way rather than in a watch table. Okay, let's orientate the factory I/O scene a little better so we can access the function panel. Oops, let's go into play mode first. Think we have forgotten to connect, so let's do that. Then start factory I/O. Now let's go into auto and press start. Okay, here we go. Let's zoom right in. Great, that works. The forks come out and then the pallet is lifted. So we now need to enter step 3, where we retract the forks into the mid position. So let's stop factory I/O, reorientate the scene, and stop the PLC. Right, let's have a talk about word to shift and why I've chosen to do things this way. Now here's a diagram of a 16-bit word, although the actual word we used in the code is a 32-bit integer double word. But the process is the same for a 16-bit word as for a 32-bit word, as we will see in this diagram. So let's refer to this as QD108, the double integer word used in the program. So in the initialize region of the code, as soon as a pallet is detected by reflective sensor 5, because the value QD108 is 0, as seen in this diagram, and the forks are in their mid position, we move the value 1 into QD108, which now signifies we have moved to step 1 in the process, and we are ready to pick up a pallet and place it in the rack. Therefore, we extend the forks, and when that is done, we move the value of 2 into QD108, which now means we can go to step 2 in the process, where we pick up the pallet. Once we've picked up the pallet, we can then move to the next step in the process, step 3, and move the value 4 into QD108, and so on, until we've gone through all 9 steps required to place a pallet in the rack, and return the stacker crane ready to pick up another pallet. Now we could have chosen to increment QD108 by 1 each time we were ready to move to the next step in the process, but essentially I chose to shift left the value in QD108 instead, even though we're not using the shift left command per se. It doesn't really matter which method we use to keep track of where we are in the process, as long as we use a method that works. I actually did consider using the shift left command, but decided against it, as moving the value required into QD108 is easier. Although I didn't rename QD108, I decided to leave it as word to shift. Once we get to step 9, where the value in QD108 is 256, we can then reset everything back to 0 and start again. So hope that explanation helps. Right, now with that in mind, let's move on and enter code for step 3 in the process. Let's create another region and name it step 3. Oops, let's delete the characters we don't need and enter. Actually, what I'm going to add to the region names from now on is the value in QD108. In this case, I'll type in val4 and enter. In the comment area, I'll type in forks to center. Okay, let's just delete the underscore from the region name to keep everything consistent. Now let's enter an if statement. Remove the new comment area, and in the condition field, select word to shift and set it equal to 4. Then we need an AND followed by timer 1 done, which we started in the previous region. So why did I use a timer here, you may ask? Well, unlike sending the forks to positions right, mid, or to the left, as we did in step 2, knowing when they reach their correct limit, because of sensors, there are no sensors for lift limits up and down. So when in step 2 we set word to shift as 4 while we were picking up the pallet, if we didn't have some way of stopping step 3 starting up at the same time, where we were about to return the forks to the mid position, the pallet would be returning to its mid position at the same time as lifting, and may cause the pallet not to be mounted properly on the forks. So we needed to start timer 1 in step 2 and check for the done signal in this. the next step in the procedure before returning the forks to mid position. So with this in mind, when word to shift is 4 and timer 1 done, then we can set output stacker crane left to false, which will send the forks back to their center position. Now we also need to reset the timer by setting it to false. And then we can move 8 into word to shift, ready for the next step in the process. I'm just going to close some of the regions up to give us more room on screen. Okay. Now it looks as though we have an error in the if statement still. Yes, the syntax of equal should not have a colon in, so let's remove that. And we are now fine. Now we're ready for the next step in the process. So let's enter a region and name it step 4 and enter. Oops, not forgetting val 8 and enter. And in this region we are going to move the stacker crane to the appropriate position in the rack. So the comment will be move stacker crane to destination, and then we can bring in an if statement. Now before we move the stacker crane to the rack, we need to check for the following conditions. Firstly, that the stacker crane is in its mid position and word to shift is equal to 8. Then we can set the destination to equal destination plus 1, which is a way of incrementing a count. And if you can remember, we set destination to 0 at startup. Therefore, the destination will be set to 1 this time, and next time 2, and so on all the way up to 54. Now we can set the stacker crane target position to the value in the destination. Then we move 16 into word to shift, and we also need to start the timer again. Why we start the timer will become clearer in the next region. Okay, let's just tidy that up a bit. Then we'll just test the program so far and see if it's working as expected. So download to device. That all loaded smoothly. So let's start up the PLC. Put factory I/O into run mode and just orientate factory I/O so we can go into auto and press start. And let's see what happens. The first pallet is picked up and moves to position 1, then stops. Fabulous. Let's just rotate the scene around and get a closer look. All looks good. Let's stop factory I/O. Let's create another region. But first, let's stop the PLC. Okay, now let's name the region step 5, val 16. And enter the comment, move forks right into rack. Now let's insert an if statement. And before we enter a condition to move the forks right into the rack, let's have a look at the host tags in factory I/O by selecting driver. Now we can see stacker crane 1 moving X and Z on inputs 1.6 and 1.7, which are sensors detecting movement when the stacker crane moves to a destination. That could be in the rack or back to accept another pallet from the loading conveyor. We set these tags up in tag table 2. So let's enter the condition and explain it as we go along. Let's enter a not. I'll just delete the comment. Okay, now if the stacker crane is not moving in the X direction and the stacker crane is not moving in the Z direction upwards, then it must be stationary. However, the stacker crane was stationary before we asked it to move to the destination in region step 4, which is why we needed to start a timer to give the stacker crane time to start moving before we carry out step 5. So let's finish off the if statement and include the timer. So and timer 1 done, which we started in the previous region, and also word to shift equal to 16. Then we need the forks to go to the right in the rack, so O_SCRA 1 right equal true. Now if we hadn't used a timer, the forks would have gone right as soon as the word to shift in region step 4 was set to 16. So I hope that explains why we need a timer to start in step 4. Now we need to reset the timer, so timer 1 start equals false. And the last action is word to shift equal 32. So let's test the program again by downloading the code to the PLC. Then let's run the PLC and orientate factory I/O before we put it into run mode. Select auto and press the start button. Let's rotate the scene around so we can see the forks go into the rack. The pallet is picked up, taken to destination 1, and the forks extend to the right. Great, that's working fine. Okay, I've gone on quite a while, so let's stop the system and save what we've done so far. So that's it for this video. In the next video, we'll finish entering the SCL code to pick up the pallets and move them into the rack until the rack is completely full, after which the stacker crane will come to a halt. So, hope you enjoyed this video. Please remember to subscribe and hit the bell so that you'll be informed of future video uploads as soon as they become available. And also feel free to make any comments. Until next time, thanks for watching and hope you have a good day. Bye for now.